Previously we have seen how data is transmitted over the air, but these data are transmitted in multiple streams for better efficiency. But how are these signals classified? Who maps them to the corresponding channel? Hello everyone, welcome back to Fundamentals of 4G. Today we will discuss logical and transport channels.
The work of telecom operator is to deliver information to end users faithfully, using complex techniques. These information are transferred through various paths known as channels. To understand this complex concept, let us take a simple real-life example. Consider a case of a big logistics company, such as India Post. Every day thousands of different kinds of mails, or goods, such as normal post, speed post, books, mobiles, soft toys, clothes, jewelries, shoes, TV, refrigerators, cars, etc. comes to its office for delivery. And for secure and efficient delivery of the mentioned items, the company will use different modes of transport systems. The mode of transportation may vary, from two-wheelers, four-wheelers, 16-wheeler vehicles, etc. Now, it is almost impossible for a single team to handle the overall process and effectively route all these products to its destination. So, the company executes this process simply by splitting the work among multiple teams. First team, let's say Team X, has clear information about the products. It categorizes them logically, such as lightweight, heavyweight, heavy automobiles, books, clothing, etc. Team X then hand it over to Team Y. Now, based on the segmentation logic passed by Team X, Team Y decides the mode of transportation to be used. For example, two-wheelers will carry lightweight goods. Trucks will carry heavyweight goods. 16-wheeler container will carry heavy automobiles. Rest categories can be mapped in a dedicated transport group.
In addition to that, Team Y also has to decide, 1. If delivery failed to reach destination, Team Y can either cancel the delivery or go for different mode of transportation. 2. If there are multiple product categories in a single transport system like dedicated transport group, team can set priority as per requirement or situation. So Team X and Team Y takes the decisions, but the vehicle arrangement and the physical transportation is executed by Team Z. Here, Team Z is working at the front end, and is actually transferring the items. Now, let's say an TV needs to be delivered. So Team X and Team Y have categorized it as heavyweight, which needs to be transported in truck. Now the same vehicle is carrying other items such as refrigerators, microwave, other TVs, etc. So at offloading point the person has to go through all the packages to extract the exact TV and hand it over. So, for convenience, Team Z will arranges the packages in a defined way, and also keeps a record of arrangements, so during offloading they can efficiently extract the item and deliver it. From this example we can say, Team X decides what is to be transported. Team Y decides how it is going to be transported. And Team Z acts on where exactly it has to be transported.
Now, let us understand how similar concept is implemented in telecom network. As we said earlier, telecom operator has to deliver data to the users using complex techniques. These data can be classified on application layer as user plane data, which is actual data intended for user. Control plane data, the data which are necessary for successful delivery of user plane data. These control plane and user plane data are further classified for efficient delivery, which is similar to the role of Team X in real-life example. Here in LTE protocol stack, radio link control layer performs this logical categorization, and the process is known as RLC segmentation or concatenation.
So, there are 5 logical channels for control plane traffic. Paging control channel. This channel carries paging messages, which the E node B transmits if it wishes to contact mobiles that are in idle state. Broadcast Control Channel is the most vital channel. It is used for broadcasting system control information to the mobile terminals in the cell, including downlink system bandwidth, antenna configuration, reference signal power, etc. Common Control Channel, when device switched on, and device is attempting to latch to the network, it doesn't have any radio connection established. So the device uses this channel for exchanging control information. Dedicated Control Channel, once dedicated radio bearer resource has been set up at both device and eNode B end, dedicated control channel is used to transfer control info. Multicast Control Channel, this channel is used to carry control informations of a group of users in a cell for multicast broadcast services. There are two logical channels for user plane traffic. Dedicated Traffic Channel, this channel is used for both uplink and downlink of user plane data between user and network. Multicast Traffic Channel, this is a unidirectional channel. It is used to transmit traffic data from the network to multiple of users for multicast broadcast services, such as real-time broadcasting of sports, events, etc. These all channels are like Team X in our example, who decide or segregate the traffic on the basis of type of data.
After segregation, we need to think of transportation for every logical channel. This is similar to assigning of transport vehicle in our example, which was performed by Team Y. Here this task is performed by MAC layer. In downlink, 4 type of transport channels are used, from which the paging, broadcast channel are mapped one-to-one from respected logical channels, and remaining downlink shared channel are mapped from multiple logical channels. Now, we said earlier that broadcast channel is used to broadcast system information, and this contains large number of signaling data. So, the system information is split into 2 parts. MIB, Master Information Block, since it carries a system critical information to acquire the cell, and it passes through broadcast channel. SIB, System Information Block. It contains other dynamic system information to access the cell, so it passes through downlink shared channel. In order to maintain healthy radio connection between user and network, user should have dynamic information of that cell, and for that user has to decode SIB from downlink shared channel, which transmitted to resource element on physical resource block. But user is unaware of this physical resource block, so user has to decode MIB first, which gives system critical information along with scheduling information for SIB. Then SIB can be decoded.
The transport channels used in uplink are similar to downlink. The logical channels such as Common Control, Dedicated Control and Dedicated Traffic channels are mapped into the uplink shared channel. As there are no paging, broadcasting and multicasting messages in uplink direction, so this channel is not present in uplink direction. However, there is one more channel in transport that has no corresponding logical channel in uplink direction. That is random access channel. At the initial stages, the user is not synchronized in uplink, and user cannot send any data without getting synchronized in uplink direction. So random access process is initiated for uplink synchronization. What we have seen so far is, in LTE protocol stack, the logical layer, known as radio link control, segregates the data from upper layer into different groups. Then the transport layer, known as medium access control layer, maps them to physical layer through transport channels. But mapping multiple logical channels in a transport channel, or simple words multiplexing the logical channel, is not the only job of MAC layer. As per 3GPP 36.321, the functions of MAC layer are 1. Multiplexing, demultiplexing of logical channels, which is already discussed. 2. Logical channel prioritization. We have shown in the example earlier that sometimes many dissimilar items were grouped in the dedicated transport group. Similarly, in shared transport channel, for uplink and downlink, multiple logical channels are mapped. It is the work of MAC layer to prioritize these channels and assign them resources accordingly. 3. Hybrid ARQ retransmission, which stands for Hybrid Automatic Repeat Request. If somehow the receiver's MAC layer could not decode the data or the decoded data was found to be corrupted, then the receiver's MAC layer will send negative acknowledgement. Based on that, the transmitter's MAC layer will have to retransmit. 4. Random access control. As told earlier, the random access channel is the only transport layer channel that doesn't have any logical channel. RATCH process is solely taken care by MAC layer.
So friends, we have seen how data are sorted and mapped into various transport channels. In our next video we will discuss the function of MAC control and the brain behind all these operation, which is MAC scheduler module. We will also discuss the functioning of TMZ, or the physical channels which actually transports the data. You can comment your doubts or suggestions and subscribe to our channel to stay updated. Happy learning!